Okay. Hey everyone, welcome to the last stream of this year, I'm pretty sure. In this one we'll be building a holiday a festival or holiday model and showing a little bit on how to handle the dataset as well. So I hope everyone can hear me well and see me well, but let's get into it. There we go. So to start with, this is how the data set, which will look like, and thank you, Caroline. I searched long and hard for it, for the hat. But the dataset we'll be using is this one from Kaggle, a recognition of festivals. So granted, it's not only Christmas holidays here. Independence Day, I would argue, for some countries is quite far away from the winter holidays, but we have some festivities here as well for the season. So I went ahead and downloaded this dataset, and we can take a look at it. It'll look like something like this. So you'll have a bunch of different folders, and each folder is essentially just one class. And then each class have a bunch of different images in them, and they are ranked in their order of the name. So 0 will appear first, all the way down to 644. There's roughly 4,000 images in total. This format we're looking at right now is very much the format which Keras automatically reads in. But to shape it more to PerceptiLabs format, I created a little pre-processing script which essentially just takes these images, it places them all into one folder, and then creates labels as well. Thank you, Anna. So let's start with going over the script. And one thing as well, or one little peek into the future. We're currently looking into changing the data processing of PerceptiLabs a bit, or the data reading. So it'll be a bit more intuitive, and hopefully you won't have to do this pre-processing script for most of your data sets. But it's not too bad. And I'll share with this one. This one will work for any image classification data set which looks like this one. So what we're doing here is just we're taking my folder and we're fetching all the different files inside the folder, and then I just add them to a list. And what we do after that is we shuffle them, and there's a shuffling inside of PerceptiLabs, but it only shuffles after you have divided your dataset into different partitions. So if you have a unshuffled dataset, so it's in the correct orders, in other words, the Independence Day and Lori, I hope I didn't mispronounce that, will be at the very end, then your testing dataset is going to consist only of samples from these two. So to prevent that, we shuffle our datasets, randomize it before we add it to PerceptiLabs. This is another feature we'll be adding as a little checkbox to the data component in PerceptiLabs later on though. So we shuffle it, and then we just go through all our shuffled files. We name them from 0 to 4,000 whatever, and then we just I do a little resizing as well. Make them slightly smaller so my computer won't complain as much while I'm streaming at the same time. And that's everything. We just throw them into the new folder which we call all files. And at the very end we also create a NumPy file called labels. And this one contains all the different classes. And the classes we create by essentially just taking the directory, the number of folders in the directory, and adding a number to them. So it's going to be 600 something of class 0, which is the Christmas, etc, etc. So let's run this one. What is called image. There we go. And we'll start generating a bunch of images. So you can see here, they're completely randomized compared to how they would be before. And as soon as it's read in all the different images, we will also get the little numpy file at the end, which is just a list or numpy array. There we go, of all the different classes, or from 0 to 6. Alright, so now we have the data. So then we can just jump straight into PerceptiLabs and start using it. And I forgot to turn on the kernel. I'm also running on a dev environment, so I have a few more recent features which will soon come out. It looks a little bit fresher here and there. So we're starting that one. Can create a new model. Alright, and first thing to do with every model, as usual, is just to read in the data. We now have that already prepared for us, so we want to read in the all files. And this will be our data input. Then we're also going to want to read in all the labels. Maybe not the most Christmassy example we got there, but we'll see if we can find some when we're running the model. And now we can start building the classification model. We can start very simply with just a dense component and see what happens if we do that. I have a feeling that it's not going to be complex enough, and just straight up get 0 gradients at some point. It won't learn because it doesn't have enough complexity in it. But let's give it a try and see what happens. While this one is loading, I can show quick one of the new features we will get in. That one crashes. These are different. Oh, here we go. You can even see the error now. That was not intended, but it worked out well. We have a slightly updated code editor. So this is the same one as in Visual Studio Code, and it's really smooth to just search things around and see what's actually happening. And it's slightly better as well at jumping to the it jumps directly to where your error is, so you don't have to go looking through the code, which you had to do before. Let's set that one to 7. And if you're wondering why I'm setting both of these to 7, it's because we have 7 different classes. So hopefully this one's going to output a 1 at whichever position represents the class. Similarly, how this one is class 3, so it has a 1 at position 3, or actually at position 4 because 0 is 1 as well. But okay, then let's try running it and see what happens. Here we go. So the first thing we can see is that we have outputs in the order of 100 or 1,000 even, which is a little bit larger than the one we might have been hoping for. And it doesn't seem to go down especially well. But let's take a look quick at the gradients and see if they're actually learning anything. Oh, they actually are. Okay, that's a surprise. I thought they were going to be flat 0. Well, if they're actually learning something, we can try upping the learning rate and see if we get some success with that. Dana had a question. Can I clarify how the numeric labels correspond to various holidays? Sure. Let me do that real quick while this one's finishing training. So the different labels, I assign them so that 0 will be the first map, 1 second, and so on and so on. So in other words, the label 0 corresponds to all the images inside Christmas. 1 inside all the images represents all the images inside Diwali, and so on and so on. So very simple, we just have 7 different festivals and 7 different classes. The only thing additional I did was just randomize the different images in which order they were placed, and that way we could avoid a bunch of images being grouped together inside the test dataset or inside the validation dataset. So I don't think this training went too well. I mean, it did learn, but it didn't learn well. So my next step was going to increase the complexity of the model, but now I'm just kind of curious what happens if we do this. And what I just did here is increase the learning rate by tenfold, which means it's either going to get stuck in a local minima, and again gradient's going to get to 0 because it's no longer learning anything because it thinks it's optimal. That's what the local minima means, or any minima. Or it's going to get these ridiculously high integers or outputs down much quicker, and maybe we can land at some reasonable classification. Let's see if this one does not start improving pretty quickly, though. I think we're just gonna try adding some more complexity to it and maybe go back to... Hey, I changed the output activation function to num rather than the standard softmax dense comes with. Usually you want to do that because no activation function means less complexity, and it's the output layer anyway. You don't need linearity there, non-linearity there, typically. But sometimes this is a little bit magic, so we can always try adding that activation function back again and see if that helps. Okay, yeah, this loss is not looking very good. The gradients are oscillating quite a lot, and so is the loss. Which I guess should I mention would be another option for increasing the training step, or the learning rate rather. So let's stop this one and go back and try something else. Alright, let's try throwing this softmax back in, and let's add in some convolutional layers and see if that helps any. So for a MNIST, just one single convolution with one dense component would be fine. Actually, for MNIST, probably just one dense component would be fine. But this is our standard template, which works well on it. So let's see if this smaller model can handle this training data as well. Might have to reconnect this one. There we go. There we go. Again, beta version or dev version. There are some peculiarities here and there. So let's try like this. See what happens now. Okay, there we go. You know, I probably shouldn't have chosen the softmax. I probably should have taken well, any other activation function instead. We can go back and change that one as well. Let's take a look now how the loss and everything's looking. If it got any better, or if it's just... Nope, that's not better. Alright, do we have sigmoid usually? We have sigmoid usually on it. Let's try out sigmoid. So softmax, what it does is it essentially normalizes all the outputs to 1, which in that case I'm guessing meant that one output, as we saw before with no activation function, was just extreme. And it essentially just always took that output. Sigmoid, on the other hand, keeps everything nicely between, I believe, -1 and 1. Is it 0 and 1? So let's run with that one instead. So what we're essentially doing with sigmoid now, even though it does introduce more complexity to the model, which traditionally or usually is not needed, it forces the output down to a reasonable level, so it might be slightly easier for the model to find the correct output. Because the goal again is we want a 1 where the class is 1. So anything we can do to help that. Good question, Dana. He asks what start training with weights mean, which is a pop-up you've seen almost every time I press on start now. What it means is if you already have trained the model, we will automatically save the weights for you, or all the variables of the model will save for you, so that you can easily export it or train on top of the model. So if you start training with weights, what you essentially do is you take your last trained model, the save state of it, and you just use how good that model already was and start training from that point, which is a really handy thing to do if you say you have a huge object detection model, or you want to train object detection, and the models are usually quite large and they take a lot of data and a lot of time to train. So what you then can do is just take a model which already has been trained and use your data to train on top of it, which goes a lot quicker than training from scratch. And there are a bunch of other techniques here where, for example, you only train on the last layer or things like that, but essentially what it means, that pop-up, is if you want to train from your last trained model. Something's telling me that this one's not going very well either. Alright, I'm gonna try to introduce in one more convolution. If that does not work, we'll go back to having no output, because that actually, even though it didn't perform very well, it did give some nice gradients, and it did actually learn. So it could be that we can go back to trying with no output. We can have a little bit more complexity, and then we can simply just train it for longer. And one easy way to do that is, in this case where we don't have a lot of time, is just introduce upping the batch size. Also just realized that I never changed the learning rate back. So let's do that. Okay, two more things we can do. If we're anyway gonna try this one, we can change this to ReLU, which usually is a little bit faster than Sigmoid, but also performs really well on images. And then we can up the feature maps a little bit more as well. Let's change that. Let's change that and go 32. So the feature map choice I did here, I essentially just doubled it. Again, trying to go to not the extreme, but trying to add a little bit maybe more complexity than needed, just to see would it do anything. Can we start seeing some gradients? Can we does it help with the more complexity? And I chose 16 and 32, where that is fairly standard to go just to double up on the feature maps for each consecutive convolution you take or you add. This one is taking longer to load than I would think though. One easy thing to check if things are taking longer is just to jump into the console and see if you still are getting messages, which it looks like we are. So it's still alive. I think it's just my laptop complaining a bit. I should get this one running on our Docker version instead. There we go. So let's run it. So here would be the choice of running with weights or not. The last model we ran had a convolution and a dense, so we'll only get weights on those two components. And what's more is that we changed the setting on the convolution, so there might be a collision with the weights. So if you're gonna use weights, be careful that you don't change up the architecture too much between the how it looked like your previous training and how it looked like the new one. Because if you change too many things, it might just not work. Adding new layers and deleting layers are completely fine, though. It's just changing the settings in layers which already existed. Okay, and it went straight to 0. Either that or it was so large before that we could... the difference is too small to see, but we can also see on the loss it just flattens out. Okay, so the next steps I would try is going back to none on this one and maybe just having one convolution component again. I think we're running out of time for today, unfortunately. But if anyone want to try it, the dataset is very easily downloadable from the Kaggle. The link is in the video description as well. Here we go. Actually, we can just start running it. But yeah, the link is very easily downloadable. The dataset is very easily downloadable, and we might upload this pre-processing script as well. Although if you're interested in trying it before we have time to do that, or if we do it, just feel free to reach out and I can hand it to you. Before we stop though, I am curious to see if this one works better. we are back to having gradients, and yeah, the numbers are not looking ridiculously high any longer, so there's a good chance that this one will work pretty well, given enough time to train. So lesson learned, for this dataset, don't use any activation function for output, and introduce a little bit extra complexity by a convolution layer, for example. But thank you everyone very much for watching, and I wish you all a very happy winter holiday, or Christmas, whatever you celebrate. Take care and see you in the new year. Goodbye everyone.